Students, good morning. Today, let us move to one more concept called lens. We have studied refraction through curved surface, right? We obtained an expression there. Which expression? Like N2 by V minus N1 by U, which is equal to N2 minus N1 divided by R, where R is radius of curvature. Now, what is the meaning of lens? What do you mean by lens? Remember, lens is an optical medium. Lens is an optical medium. Optical medium means related to light, related to refraction of light. Lens is an optical medium bounded by two surfaces. Surface 1 and surface 2. Let me repeat now. A lens is an optical medium bounded by two surfaces. But there is condition. At least one of which is spherical. There is no need that both the surfaces must be what? Spherical. A lens is an optical medium bounded by two surfaces, at least one of which is sphere, one of which is spherical. If one surface is spherical, then it is called lens. Why? Why? Because we have different kinds of lenses. Let me show you one by one. This lens is called convex lens, biconvex lens. Best term is biconvex lens. Biconvex lens. This lens is called concave lens. Biconcave lens. Concave lens or biconcave lens. Remember, these two lenses have curved surfaces. Both the surfaces are curved. Okay? We have one more category of lens. See, this is also a lens. This is also a lens. Visible. This is also a lens. What lens? This surface is plane. This surface is convex. So this lens is called plano convex lens. I hope you understand. Now, this word is good for that definition. A lens is an optical medium bounded by two surfaces, at least one of which is spherical. ಒಂದು ಲೆನ್ಸ್ ಅಲ್ಲಿ ಒಂದು ಸರ್ಫೇಸ್ ಸ್ಪೆರಿಕಲ್ ಇದ್ರೆ ಆಯ್ತು, ಮತ್ತೊಂದು ಸ್ಪೆರಿಕಲ್ ಇರಬೇಕಂತ ಇಲ್ಲ. ಇದು ಸ್ಪೆಷಲ್ ಕೇಸ್. In that sense, this is special case where we have two spherical surfaces. This is also special case where we have two spherical surfaces. We have one more kind of lens of this kind. This lens is called, of course, what? Plano. This side is plane. Plano. This side is concave. Concave lens. Plano concave lens. And now, see, this is also kind of lens. Remember, this is also kind of lens. This surface is concave in nature. This surface is convex in nature. So, name of this lens will be concavo-convex lens. What? Concavo-convex lens. Concavo-convex lens. Concave this side, convex this side. We have this lens also there. where this surface is convex, this surface is concave. Hence, this lens is called, of course, you know that convexo, first surface, concave lens. Convexo, concave lens. These are some kinds of lenses. And one more thing, whatever laws, sight conventions we apply to the mirrors are equally we can apply to the lens also. We can apply those laws of conventions, sign conventions equally to lenses also. First. Second thing, see here. Let me take convex lens as a standard lens now. Okay, to study some of the properties. This is a lens, correct? We can imagine this lens is due to intersection of two spheres. This one is pointing right. Okay, somewhat okay, right? See, this is the lens, correct? We can imagine this lens as it is formed due to intersection of two spheres. What? It is formed due to intersection of two spheres. Then I will draw a line. This will be center of the lens. This point represents center of your lens, and it is called optical center. Okay? Optical center. Let O be the optical center. This sphere has center. Of course, this sphere has a center, and also this sphere has one more center. To distinguish this sphere, let me call this as C1, center of first sphere. Let me call this as C2, center of second sphere. A line joining from circumference of first lens, see now, circumference of first lens is radius of curvature of first sphere. Radius of curvature of first spherical surface R1. Now, a line joining from the second surface, circumference of second surface to C2 will give you R2. So, in case of lens, you have two radius of curvature or radii, R-A-D-I-I, radii. Here, radii R1 and R2. Correct? Of course, two focal length also. Okay, next. Now, if this is clear, let me take this lens. Here you have a line passing through optic center is called principal axis. No doubt in that. This is a principal axis, center. When a ray of light is allowed to incident on this lens at any point, we observe after refraction. Here we observe refraction twice, two times. How? One, if it is air, say, let me take it as air. This is also air. We observe double refraction. Refraction two times. First refraction, air and denser medium, glass, better. Air and glass. At point, say A. At point A, we observe refraction of a light from air to glass. Correct? At surface B, we observe refraction from glass to air. Glass to air. Correct? After refraction, this refracted ray meet your principal axis at a particular point, as in case of your mirror, concave mirror, or any kind of mirror. Then this is called principal focus. This is called principal focus. Suppose that a ray of light is allowed to incident in this direction. There is no hard and fast rule that every time ray must travel in this direction only. Ray can travel in that direction also. Then what? Then of course, after reflection, what we observe? A ray will reach a common point on principal axis. Now we have two focal lengths. Focal length, two. One to this side, one to that side. So it is called foci, foci, or foci, which is easier you can call. Foci, foci, plural of focal length. I mean, principal focus. Focus. Principal of focus. I mean, plural of focus. Foci. Foci. If you consider this as a ray, this as incident ray, then this focal length is called second principal focus. Let me repeat. If you consider this incident ray as a standard one, then after refraction, the point where refracted ray meet on this principal axis is called second principal. I mean, second focus. Second principal focus. Second principal focus. We represent it as F2. We represent it as F2 or F dash, whatever it may be. This principal focus is called first principal focus. This is called first principal focus, or simply first focus. This is called second principal focus, or simply second focus. So we have foci in case of lenses. In case of lenses. Let me repeat. If this is incident ray, the focal length in the side of incident ray is called first principal focus. The principal focus where refracted ray meets the principal axis is called second principal focus. Yeah. They can interchange. If you consider this as standard, then automatically this will be second principal focus. Hope you understand. Very simple. Okay. And this lens, which we call it as convex lens, is often called as what? Converging lens. What? Converging lens. In air, this lens is called converging lens. Why? When paraxial rays, which are parallel to principal axis. Let us take one more ray along principal axis also, which is normal. This is optical center O. Whenever paraxial rays allow to fall on your convex lens, then what we observe? After refraction, they meet a certain point.